Hello everyone. So welcome to the last video of this internal series where we have covered ABC sections, and and in this video I'm gonna cover section D, which is about Python data structures, and we are gonna start from 41 question in which we are gonna talk about list. So what are list? So in Python, sometimes you need a shopping list where you can add or cross off item letter, right? Lists are built for that. They are flexible. You can change them even after you created them. That's called mutability. The technical term for this is mutable. Lists are ordered and mutable, meaning that they can be changed even after doing all of your works. You can still change it. Now comes the turn for tuples that are immutable. Like you cannot change it. Like when you want the data that cannot be changed, it has to be a permanent thing. So there comes the use of tuples in data structure. So you don't accidentally mess with them, right? Right? That is where tuples comes in. Once you write them, they are locked in. They are the safe, unchangeable version of a list. Tuple differs from list because they are immutable. Now comes the turn for dictionaries. 43 question. So imagine looking up a phone number, you don't read the whole phone book. Instead, you look for the name to find the number, right? So in this we are gonna talk about keys and values. So keys are the variables and values are the actual numbers. Like for example, in this case that where we've talked about the phone number, right? So the people actually don't remember the phone numbers. They remember the name of the person whose phone number that is. So for example, if I have given a key of my name Rohan and my so when I've given my name as a variable as a key in the dictionary, then my then the value for my name variable would be my number, right? So Python dictionaries work exactly like that. You use a unique key, the name, and instantly access the value, the number. Dictionaries stores data as a key value pair. So now comes 44th question, that sets. So imagine you have a list of RSVPs for a party, but some people reply twice. You need a clean list with no duplicates. You convert a list to a set. Set are magic because they physically refuse to hold the same item twice. They automatically delete duplicates. Set contains only unique elements. That's why they delete all the duplicate elements. So here comes the turn for DQs, that are the 45th question of this section D. So a normal line is the first come, first served. But sometimes you need to cut the line from the front or the back. A DQ, double-ended queue, is designed exactly for this. It is optimized to add or remove things from both ends intentionally. A DQ allows fast operations with both sides. That's why they are used very frequently. Even I like using DQs. 46th question of section D, that's about counters. So suppose you want to count how many times the word apple appears in the book. Writing a loop for that is annoying. Where Python has a special tool called counter where you just feed it the data and it builds a dictionary telling you exactly how many times each item appears. Counter is a subclass of dictionary that tiles occurrence. 47th question, that's about frozen sets. So we know set are great, but because they change, can't use we can't use them as a key in the dictionary. So Python gets confused with this. So there comes the role of frozen set. So it acts like a set, but it's frozen. You can't change it. It's logged in. It can't be changed. Because it is static, Python is happy to use it as a key for the dictionary. So a frozen set is a set that is immutable. Now comes 48th question, priority queues. So in a hospital ER, patients aren't treated in order of arrival. They are treated by who is sickest means who is the sickest patient over. So that is the priority system. Heap queue model allows us to organize data not by arrival time but by importance or values. So the heap queue model implements the priority queues. Here comes the turn for the 49th question, that is on max heap. So look at the structure of a heap and imagine a corporate hierarchy there, and where the CEO is at the top, where in a max heap every boss parent node must be bigger or more valuable than the employees children nodes below them. In a max heap each parent node value is greater than its children's. 44 seconds. Now comes the last question of the series. So here comes the 50th question, the last one of the section D, which talks about hippify function. So hippify in shorter way, if I say you, it is used to sort a list in a ordered way where it converts a list into a heap order, and this is called hippify. So let me just read it out for you. So you have a messy random list of numbers and you need to turn them into a structured heap instantly. So what you do, you don't need to sort it slowly. You just need to run the heapify function that shuffles the list elements in orders in place, and it plays to satisfy the heaps rule instantly. So this is what we call heapify. Converting a list into heap order is called heapify. So thank you for watching this video. I hope you like the videos, and thank you for watching. So here comes the turn for the question 37, where it takes us back to the algebra phase, where neural network is basically a giant math equation, which is y is equals to mx plus b, where the network learns by tweaking the slope m and intercepts b until the answer is correct. In AI terms, we call this weights and biases. So the linear classifiers combines input with weights and biases to form a prediction. So that's where this algebra comes into the play, where the linear classifiers combines input and with and forms predictions with weights and biases. So coming to the 38th question, which is on activation functions. So here is the issue. If you stack 100 layer linear equation, we still just get a straight line. Oh, so what? But the real world is curved and complex. So we inject a special function just like a switch, the bands and the line. This follows the neural network. So here comes the turn for the question 37, weights and biases. So neural network is basically a giant math equation which is y is equals to mx plus b, where the network learns by tweaking the slope m and intercepts b until the correct answer is gained out. So in AI terms, we call this weights and biases, where linear classifiers combine input with weights and biases to form predictions. Question 38 is the next, on which we are going to talk about activation functions. So here comes the issue. If you stack 100 linear equation, we still get the straight line, but the real world is curved and complex. So there we inject a special function like a switch that bends the line. This allows the neural network to learn complex shapes. Activation functions introduce non-linearity into neural models. Question 39, we are going to talk about capacity. So think of a model that has a model's brain size, sorry. So think of a model's brain size where a small model can't learn quantum physics. It's too simple. If we add more neurons and more layers, we are giving the model more brain power to understand difficult patterns. Adding neurons or or hidden layers increases the model capacity. Question 40.